Hello. What we're going to do today is going to complete the valuation module by talking about the corporate valuation model. It's going to be very similar to the dividend discounted model, and also this is frequently known as the free cash flow model. Let's get into it. What we're going to say here is that the value of the entire firm equals the present value of the firm's free cash flows. Remember that the free cash flows are the after-tax operating income minus the net capital investment. So if this formula down here looks familiar, it's because it is exactly the same as the one that we had for the dividend discounted model. Instead of dividends here, we have free cash flows, and instead of the price of the company, the price of per share at time zero, we have firm value, because these are the cash flows of the whole company. Other than that, the formula is the same. So a little word about free cash flow. This is what we should do. This formula here, what we end up doing many times is just getting net income and depreciation and taking capital expenses out. Just a note of caution here. We'll talk more about this in class. So we're supposed to estimate cash flows all the way until infinity. The near future is somehow predictable. However, knowing from the results of the election, even the near future is not that easy to predict, right? So the near future is somehow predictable. Time value of money makes these cash flows very important. So we're actually going to estimate these cash flows. We're going to go through the troubles trying to find out, well, how many phones are we going to sell? How many customers is this new restaurant going to have? What is the cost of the food going to be, etc. In the far future, meaning from years 5 to infinity, year 6 in general, for infinity it's not so easy to predict, and actually the cash flows that are going to take place in 6 years from now are not that important. When we calculate the present value of them, it really doesn't matter if we get them 5-10% wrong, etc. So what we're going to do is just going to assume a growth rate and estimate a horizon value, just like we did for the dividend growth model. So what's the ingredients that we need for this mix? Operational cash flows. We need our EBIT, the effective tax rate, what's the depreciation, what the capex. We need a horizon value, a WACC. This WACC is the weighted average cost of capital. We're going to spend a whole next chapter on this. For now, let's just say that this is the cost of the company to get operating capital. This is going to be similar to the RS, but for the company. We need a long-term growth rate, the outstanding debt in dollars, and the number of outstanding shares. Step number 1, find the market value of the company by finding the present value of the future cash flows. Number 2, take out the firm's debt out of this market value. Number 3, divide the remainder, the market value of the common stock, by the number of shares to get the price. For dividends, we will stop right in step 1. We need to do 2 more steps in the case of free cash flow models. So let's apply it. Find the market value of the firm. We're going to find the free cash flows from year 1 to 5. This way, we're going to find the horizon value by calculating the free cash flow of 6 divided by WACC minus G. Again, this is the same formula or the same idea behind the discounted dividend model. And a word on horizon value. This horizon value, this value here, represents the fact that we're simply not going to abandon our company when the year 5 comes in. We're not just going to drop it. There's always going to be value left. There's going to be equipment, land, buildings, patents, clients, know-how, a number of things. So this HV tries to capture the value of all cash flows that are going to happen from year 6 to infinity. Instead of using HV, we could have something else. We could say, well, the scrap value is. So in the case of the taxi example that we've been working in class, well, what's the salvage value for that? What is the depreciated value? Let's just assume, for example, that we're going to say, okay, 10% of the cost or 20% of the cost. Or some people will say is 0. Most of the times, these alternative values are not a good case. and we'll see why. Depending on the project, a 0 may be fine, but if there's something left, if this is an ongoing venture, HV would be the best way to go. So what are the WACC and G? WACC is the rate at which you're going to discount our cash flows. Think of it as a different RS. G is the long-term growth of the cash flows. It's our assumption for something sustainable, something that can go on forever. This model is often preferred to the discounted model, mainly because a number of companies don't even pay dividends, so it's very hard to use a model that calls for dividends when there's no dividends to be paid, and actually dividends are not that easy to forecast. It's very similar to the discounted dividend model in terms of the growth rate and in terms of the horizon value, so people are very familiar with it. So let's take this for a test drive. Ramirez company has this cash flows -5, 10 and 20, and we said that after year 3 there's going to be a 6% rate of growth. We're going to assume that RS or WACC is 10%. The company has $40 million in debt and there are 10 million shares outstanding. First thing we need to do is, well, let's calculate the value of the whole company. Again, we have the cash flows already, and remember that we had to bring all these cash flows back to times 0, so this 5 here are going to become minus 4.5 because we calculate PV of this 5 at 10% for 1 year, PV of 10 at 10% for 2 years equals 8.2. Again, pause this video, convince yourself that this is right. We have cash flow at 20, we bring it back at 15, and we calculate the horizon value at time 3, which is going to be 2120. Where does this 2120 come from? From the 20 growing at a 6% rate, 20 times 1.06. This was not given, we had to calculate it. It's calculated here. Divide over what? The WACC or RS minus G. It gives me 530 that I also need to move over here for a total of 398. I add them all up and I get 416. $416 million is the value of the whole company. The whole company. What's the value per share? Well, first we need to take out $40 million in debt. 416 minus 40 million equals 376. So think of this as your house. You buy a house, you bought it for $1 million, you borrow $800,000 from the bank, and then you sell this house. Well, once you sell the house, you're not going to get $1 million. I mean, you are going to get $1 million, but you're going to have to go to the bank and pay the loan back, right? So in the end, what you're going to get is only $200,000 for you as the equity. The same thing happens in the company. So the market value of the equity is 376. And if we know that there's 10 million shares, well, you guessed it, the price per share should be $37.69. 376 million divided by 10 million. Easy peasy? I hope so. Again, that's how we apply the model. Go back to the slides and make sure that you can make sense of them. Here's another example. Here we have cash flows 100, 120, 130, 140, 150. We have the market debt, value debt of 500, number of shares 8,750,000, discount rate of 10, growth rate of 4. Those are my assumptions. Let's calculate the horizon value. Horizon value comes from where? 156, which is going to be the dividend of 2026. I'm going to go back. Growing at 4%. 150 times 1.04 equals 156 divided by 6%, which is what? 10 minus 4 equals 2.6. In this case, I'm solving it using the NPV function, right? So these are my cash flows. 2.6 plus 150, 2.750, 140, 130. You get it. I'm calculating the value of the firm using NPV. Remember, interest rate here is the WACC, 2,090,000. This is right from Excel. 2,090,000 is the value of the whole company. I said that we have 500 million in debt. That gives us a market value of equity of 1590. 1590 divided by 8,750,000 shares gives us a value of 181.82. Make sure that these values here and these values here are expressed in the same base. So if this is 1500 million, this should be 8. If this is millions, this has to be millions as well. That's what I'm trying to say.